Okay, so good night, everyone. So hopefully tonight we only need to do this class for an hour. So I just want to cover carboxylic acid naming and also the physical properties of carboxylic acid. Okay, so shall we start? Oh, before we start, do say hi to Madden in the live chat. Okay, so we shall start. So carboxylic acid. Okay. So introduction. So what is carboxylic acid? So carboxylic acid refer to the class of compound with carboxyl group as the functional group. So carboxyl group. Mommy 在教书。我喜欢我的我。Okay, so carboxyl group basically consists of carbonyl and also hydroxyl group. Okay, so combinations of carbonyl and hydroxyl group giving us carboxyl group. Okay, so this carboxyl group basically is the functional group for carboxylic acid. And for aliphatic carboxylic acid, the general formula for aliphatic carboxylic acid is CnH2nO2. Okay, because O2 is because they are dual O. Okay, at the carboxyl group of the carboxylic acid. So for carboxylic acid, it can be divided into two types. So aliphatic carboxylic acid, where the R here is referring to any alkyl group, and also aromatic carboxylic acid, where the carboxyl group carbon is directly attached to a benzene ring. Okay, kalau the carbon of the carboxyl group directly attached to the benzene ring, then this is aromatic carboxylic acid. Okay, if it is attached to any alkyl group, the carbon of the carboxyl attached to alkyl group, then it is aliphatic carboxylic acid. So now we move on to look at IUPAC nomenclature of carboxylic acid. So basically, how to name aliphatic carboxylic acid? To name the aliphatic carboxylic acid, we need to identify and determine the parent. So how to identify and determine the parent? Kita lihat kepada longest continuous carbon chain consists of carbon of carboxyl group. Longest continuous carbon chain yang mempunyai carbon of the carboxyl group. Okay, and the carbon of the carboxyl group, we must assign it as carbon number 1. Okay, and then to give the IUPAC nomenclature or IUPAC name for carboxylic acid, so must remember the carboxyl group has the highest priority. So it must be the part of the parent. Okay, and then how do we name the carboxylic acid? So basically, like for example, if alkane 4 carbon, we call it as butane. So kalau it is a carboxylic acid, so basically we call it as butanoic acid. So the E at the back of your alkane ditukar kepada OIC. Okay, in order to name the aliphatic carboxylic acid. Okay, the E at the back of your alkane diganti dengan OIC and then acid. Now we move on to look at the first example. So can you see that for this first example, we only have one carbon as the parent. So kalau one carbon as a parent, and that is the carbon of your carboxylic acid. So kita panggil ini, kalau satu carbon, remember met. So therefore, this is called methanoic acid. Okay, so now we move on to look at the second example. Tengok sekarang, the carboxyl group is carbon number 1. This is number 2. Okay, so total 2 carbon. Therefore, this is ethanoic acid. Then we move on to look at the next example. consists of 3 carbon. So the carbon of the carboxyl group, carbon number 1, 2, 3. So this is 3 carbon prop. So therefore, this is propanoic acid. Okay, so move on to look at the next one. Consists of 4 carbon. The carbon of carboxyl must be carbon number 1, 2, 3, 4. So consists of 4 carbon. So consists of 4 carbon. So 4 carbon but. So this is carboxylic acid. Therefore, it's called butanoic acid. Okay, so the next example, okay, consists of 5 carbon. So carbon of carboxyl number 1, 2, 3, 4, 5. So 5 carbon pent. Therefore, this is called pentanoic. Okay, so pentane. So pentanoic acid. Okay. So common name adalah nama yang diberi before having the IUPAC system. Again, metanoic acid being called as formic acid, ethanoic acid, acetic acid, the propanoic acid being called as propionic acid, and butanoic acid used to be called as butyric acid, and pentanoic acid, valeric acid. So this is the common name yang diberi before the IUPAC nomenclature system. So now we move on to look at the example. So how do we name the carboxylic acid? So again, cari the longest continuous carbon chain dulu. So this is the longest continuous carbon chain. The carbon of the carboxyl is carbon number 1, number 2, number 3, 4, 5. Okay, so parent ini ada 5 carbon and this is carboxylic acid. Therefore, the parent is called pentanoic acid. And at carbon number 4, we have a substituent. So substituent ini 1 carbon methyl. So therefore, it is called 4-methyl pentanoic acid. Okay, so now we move on to look at the second example. So second example, again, this is the parent, longest continuous carbon chain. The carbon of the carboxyl is carbon number 1, number 2, number 3, 4, 5. So can you see that? Okay, 5 carbon, there are 5 carbon pent, tapi this is carbon-carbon double bond between carbon number 3 and number 4. Therefore, at carbon number 3, we have the carbon-carbon double bond, right? So therefore, we call this as pentanoic acid. Pentanoic acid. So double bond at carbon number 3, therefore, is called 3-pentanoic acid. Or we can also call it as pen 3-enoic acid. Di mana the ing ini refer to carbon-carbon double bond. So longest continuous carbon chain is this one. So carbon number 1 is the carbon of the carboxyl. 2, 3, 4, 5. Okay, so here our substituent kita ada bromo and we have methyl. So alphabetical order, B comes before M. Therefore, for this compound, it is being called as 4-bromo, 3-methyl. So 5 carbon, so pentanoic acid. Then now we move on to look at the next one. So the longest continuous carbon chain adalah ini. Again, the carbon of the carboxyl, number 1, 2, 3, 4, 5, 6. Okay, and at carbon number 5, we have the functional group, the hydroxyl group substituent. Okay, so hydroxyl substituent, ingat tak kalau hydroxyl compound become the substituent, kita panggil hydroxy. Therefore, this compound is called 5-hydroxy hexanoic, so a non-carbon hex, so hexanoic acid. Okay, so how about if a compound with 2 carboxyl group? Kalau the compound has 2 carboxyl group, then we call it as alkane dioic acid. Alkane dioic acid. So for example, so look at example 1. So this is the parent. Nampak tak kat kedua-dua hujung you have carboxyl group. So this is number 1, 2, 3, 4. So total we have 4 carbon. So 4 carbon, this is 4 carbon boot. So remember kita panggil alkane dioic acid. So therefore this is butane. Okay, so butane dioic acid. Do we need to put 1,4? No, we don't need to put 1,4 here. Kenapa? Because carboxyl group for the carboxylic acid mesti dekat hujung chain. Mesti dekat hujung chain. So if you have 2 carboxyl group, it must be dekat hujung yang pertama and the carbon yang terakhir. Because the carboxyl group must be at the end of the chain. Okay, so now we move on to look at the example 2. So where is the continuous carbon chain? So can you see that this is the longest continuous carbon chain? So can you see that this is 1, 2, 3, 1, 2, 3. Okay, so doesn't matter number from which side. So total we have 6 carbon. And then at carbon number 3, we have carbon-carbon double bond. So therefore, this is called, and then we have 2 carboxyl group. So 2 carboxyl group. So this is 3-hexene. Okay, so 3-hexene dioic acid. Okay, so 3-hexene dioic acid. 3 because carbon-carbon double bond is at carbon number 3 and 4, and then dioic because ada 2 carboxyl group both at the end. Okay, and then can you see that kat sini ada stereochemistry. So remember what stereochemistry is this? So this is the 6 trans, and then this one is opposite side. The hydrogen are at the opposite side from one another. Therefore, this is trans 3-hexanoic acid. So now we move on to look at how to name the carboxylic acid involve ring. So bermaksud kita macam mana kita nama the cyclic carboxylic acid. So to name the cyclic carboxylic acid, basically we name the cycloalkane first. So we name the cycloalkane, then belakang tambah carboxylic acid. We name the cycloalkane, belakang tambah carboxylic acid. So like for example, in the example 1, so this is cyclo 5-member ring, so cyclopentane. And then tambah carboxylic acid. So this is how we name the cyclic carboxylic acid. Okay, so now we move on to 3, 4, 5, 6. So 6 carbon, so this is called cyclohexane. Okay, and then this is carboxyl group. So therefore tambah carboxylic acid. So now we move on to look at number 3, the third example. So this is the cycloalkane. So which should be the carbon number 1? It must be the carbon yang ikat kepada carboxyl group will be the carbon number 1. Remember, carboxyl group highest priority. Okay, and then number 2, number 3, 4, 5, 6. Okay, so parent ini kita panggil cyclohexane. carboxylic acid. How about the substituent? Substituent kita ada 4-bromo dengan 3-methyl. Again, we need to arrange them in alphabetical order. B come before M. Therefore, compound ini panggil 4-bromo. Oh, sorry. So 4-bromo. Okay, so 4-bromo, 3-methyl carboxylic acid. Okay, then now we move on to look at the fourth one. So the fourth one, where is the parent? So again, this is the parent yang mempunyai carboxyl group. So this is the cycloalkene sebab ada carbon-carbon double bond. So where should be the carbon number 1? It must be the carbon yang ikat kepada carboxyl group. And this is number 2, number 3, 4, 5, 6. So untuk parent ini, we call it as, can you see that carbon-carbon double bond is at carbon number 2. So kita panggil ini, so 2-cyclohexene. So 2-cyclohexene. Okay, so 2 ini melambangkan kedudukan your carbon-carbon double bond. Okay, followed by carboxylic acid. And the substituent, kita ada 3-methyl. Therefore, the compound is called 3-methyl 2-cyclohexene carboxylic acid. So now we move on to look at how about if it is aromatic carboxylic acid. So aromatic carboxylic acid, so kita panggil dia the parent as a benzoic acid, the benzoic acid. Okay, so the carbon of the carboxyl kita tidak nombor dia. This carbon kita tidak nombor dia. Okay, but then the carbon on the benzene ring, this is carbon number 1. Okay, so now shall we move on to look at the example? So how do we name the aromatic carboxylic acid? So the carboxyl group will be part of the parent, and kita panggil ini as benzoic acid. So the carbon of the benzene ring yang ikat kepada carboxyl group, it will be carbon number 1. So substituent ini 2, 3, 4, 5, 6. So bromine is at carbon number 2. Therefore ini panggil 2-bromo benzoic acid. Or nampak tak, the carboxyl group dengan bromine, they are in a 1-2 position. Kalau 1-2 position, we can also call this as ortho-bromo benzoic acid. So now we move on to look at the next one. So carboxyl group is part of the parent, and it should be the carbon number 1. Okay, so number 2, 3, 4, 5, 6. So at carbon number 2 dengan carbon number 5, we have chloro. So therefore, this compound is called 2,5-dichloro benzoic acid. Then, how about kalau kita mempunyai 2 carboxyl group? So, kalau kita ada 2 carboxyl group, then basically, and then this is our parent. Okay, so this is our parent. So the carboxyl group is attached to carbon number 1. Okay, let me number again. So it's attached to carbon number 1, 2, 3, 4. So it's attached to carbon number 1 and carbon number 4. Okay, so yang ini benzene ring is the benzene ring, and the benzene ring and also the carboxyl group are the parent. So like this. So they are the parent. So how do we call them? So this is called 1,4-benzene dicarboxylic acid. Okay, so benzene 1,4-benzene dicarboxylic acid or benzene 1,4-dicarboxylic acid. But at carbon number 2, kita ada chloro. So therefore, it is called as 2-chloro 1,4-benzene dicarboxylic acid. So I'm done with naming. So now we move on to look at the physical properties of carboxylic acid. So the physical properties of carboxylic acid that I'm going to cover is the boiling point, solubility in water and in organic solvent, and acidity. So for the boiling point, carboxylic acid, it has relatively higher boiling point compared to other classes of compound. So berbanding dengan alcohol, ketone, aldehyde, carboxylic acid punya boiling point is the highest. Kenapa? Because between carboxylic acid molecule, they can form hydrogen bonds. They can form more hydrogen bonds, and the hydrogen bonds that can be formed between the two carboxylic acid molecule is actually very stable. Okay, so again, carboxylic acid relatively high boiling point compared to other classes of compound sebab dia boleh membentuk hydrogen bond. And the hydrogen bond formation adalah sangat stabil. Okay, because for carboxylic acid, dua carboxylic molecule, they can align in such a way that, kedua-dua molekul ini membentuk the hydrogen bond begini. Okay, antara satu sama lain. And then these two carboxylic acid molecule yang that have the intermolecular hydrogen bond, we call them as dimer. Okay, and this dimer, mereka punya mereka susun very close to one another. So this dimer, so these two carboxylic acid molecule, they are been packed close to one another. Sebab being packed very close to one another, therefore the hydrogen bonds that form between the dimers adalah sangat kuat, menyebabkan carboxylic acid has relatively higher boiling point compared to other classes of compound. So again, carboxylic acid has higher boiling point compared to other classes of compound because carboxylic acid, dua carboxylic acid molecule, they can form dimer, and between the dimer, there are strong hydrogen bonds between them. And these strong hydrogen bonds between the dimers causes carboxylic acid to have higher boiling point than other classes of compounds such as alcohol, ketone, aldehyde. Okay, and dicarboxylic acid, we expect them to have even higher boiling point. Sebab kalau dicarboxylic acid bermaksud ada dua carboxyl group, therefore can form more hydrogen bond between the molecule. Therefore, boiling point lagi tinggi. So now, shall we move on to look at the example? So can you see that here, propanol, butane, ethanoic acid, mereka punya molar mass hampir sama, tetapi the boiling point of ethanoic acid is way higher compared to butane dengan propanol. Kenapa? Again, jawapan dia dua. Sebab ethanoic acid, carboxylic acid kan? So can form hydrogen bonds yang kuat between dimers. So between the dimers can form strong hydrogen bonds. Okay, so and then selain daripada itu, so remember ethanoic acid ada carboxyl group. In the carboxyl group, the hydrogen bond can be formed. Okay, let me draw. Okay. Sini dengan sini. Okay, so means that kalau compare to propanol, the ethanoic acid can form more hydrogen bond between the molecule compared to propanol. Propanol hanya ada OH sahaja. Remember? So because of that, for propanol, we will expect propanol to have propanol form less hydrogen bond between the molecule compared to ethanoic acid. So now we move on to look at solubility of carboxylic acid in water. So carboxylic acid, okay, so yang mempunyai 1 hingga 5 carbon, they are completely soluble in water. Okay, so means that methanoic acid, ethanoic acid, propanoic acid, butanoic acid dengan pentanoic acid, they are completely soluble in water. So masih ingat tak, to be able to be soluble or dissolve in water, they must be able to form hydrogen bonds with water molecule. So in the carboxylic acid consists of carboxyl group. Can you see that carboxyl group boleh membentuk hydrogen bond? So this is the hydrogen bond with water molecule. Since carboxyl therefore the carboxylic acid yang mempunyai 1 hingga 5 carbon, they are completely soluble in water sebab boleh membentuk hydrogen bond with water. So however, solubility in water, okay, so decrease in solubility in water disebabkan oleh increase in molecular mass. Bermaksud the molecule makin besar, the carboxylic acid makin besar, okay, molar mass dia makin tinggi, okay, solubility in water makin rendah. Why? It is because when molar mass tinggi, bermaksud the size of the alkyl group ini. So this is the alkyl group. So apabila molar mass makin besar, alkyl group ini makin besar. Okay, so alkyl group consists of carbon and hydrogen, betul tak? Carbon and hydrogen. So basically alkyl group ini adalah hydrophobic area. Hydrophobic bermaksud takut kepada air. Okay, so as the molar mass bertambah, alkyl group semakin besar, hydrophobic area semakin besar, so the solubility in water semakin rendah. So shall we move on to look at the summary of this? So basically, aliphatic carboxylic acid yang mempunyai more than 5 carbon, they are insoluble in water. Kenapa? Because more than 5 carbon, bermaksud sekarang, the alkyl group sangat besar. 6, 7, 8, 9, 10, so alkyl group besar, hydrophobic area adalah sangat besar. So kalau hydrophobic area makin besar, dia makin takut air. Therefore, insoluble in water if the carboxylic acid has 5 carbon and above. So for aromatic carboxylic acid, it is only slightly soluble in water. Kenapa? So aromatic carboxylic acid, the carboxyl group is attached to benzene ring. And this benzene ring only consists of carbon dengan hydrogen, betul tak? This is also hydrophobic area. And this benzene ring, the hydrophobic area, is big. Therefore, aromatic carboxylic acid only slightly soluble in water. However, kalau number of carboxyl group bertambah, like for example ini ada 2 carboxyl group. So kalau 2 carboxyl group can form more hydrogen bond with water, therefore it will be more soluble in water. So now, shall we look at this? Arrange the solubility of the following compound in descending order. So siapa paling soluble? Okay, so of course will be S. Okay, so S is the most soluble sebab dia ada dua carboxyl group. So kalau ada dua carboxyl group, hydrogen bond with water, so therefore more soluble in water. Diikuti, so kita tengok ini. So yang ini ada berapa carbon? 1, 2, 3, 4 carbon. So 4 carbon. Yang ini it has 1, 2, 3, 4, 5. So 5 carbon. Okay, so 5 carbon besar. So Q lebih banyak carbon. So bermaksud dia punya hydrophobic group so this is hydrophobic group. Hydrophobic group dalam Q is bigger. So kalau hydrophobic group dalam Q is bigger, so Q kurang soluble. So bermaksud R is more soluble sebab dia punya hydrophobic group smaller. Yang ini hydrophobic group bigger. So therefore R lebih soluble diikuti dengan Q. For the aromatic carboxyl, it is because this is aromatic ring. So aromatic ring adalah huge hydrophobic. So hydrophobic area. So kalau huge hydrophobic area, so bermaksud least soluble. So this is descending. Order of solubility in water. Okay, so now we move on to look at solubility in organic solvent. So organic solvent boleh dibahagi kepada dua jenis, non-polar and polar organic solvent. Okay, so in order for the carboxylic acid to be soluble in the non-polar solvent, dia mesti able to form van der Waals forces with the non-polar solvent. Example of non-polar solvent adalah benzene. Okay, so carboxylic acid is soluble. They are soluble in the non-polar solvent such as benzene. So kenapa? Disebabkan ada alkyl group. Alkyl group ini adalah hydrophobic, betul tak? Hydrophobic. So hydrophobic area ini boleh membentuk van der Waals forces dengan the non-polar solvent such as benzene. So apabila the alkyl group ini, hydrophobic area ini, alkyl group ini boleh membentuk van der Waals forces dengan benzene ring, bermaksud the carboxylic acid is soluble in the non-polar solvent such as benzene. So polar solvent such as alcohol, so benzene soluble in the polar solvent juga. So polar solvent such as alcohol, kenapa the carboxylic acid soluble in polar solvent such as alcohol? Sebab dia boleh membentuk hydrogen bond with alcohol. So this is your solvent alcohol. So the carboxylic acid, so this is your carboxylic acid. Nampak tak? Dia boleh guna the carboxyl group punya hydrogen untuk membentuk hydrogen bond with the oxygen of alcohol. Selain daripada itu, the alkyl group of alcohol and the alkyl group of carboxylic acid, they can also form van der Waals forces. Okay, the two interaction, van der Waals forces and also the hydrogen bond. Since they can interact with one another using hydrogen bond and also van der Waals forces, therefore carboxylic acid is also soluble in polar solvent such as alcohol. So now we move on to look at this organic compound and then arrange them in decreasing order of solubility in water. Okay, so remember, so kalau solubility in water, so kita kena tengok, remember solubility in water, kita kena tengok boleh tak membentuk hydrogen bonds with water. Okay, so propanoic acid. So propanoic acid mempunyai carboxyl group. Carboxyl group boleh membentuk hydrogen bond with water. Therefore, propanoic acid is very soluble in water. Sebab mana tempat boleh membentuk hydrogen bond? So sini dengan sini. Okay, so in the carboxyl group, the oxygen can form the hydrogen bond with water dan juga the OH boleh membentuk hydrogen bond with water. Okay, so how about 1-butanol? In 1-butanol juga boleh membentuk hydrogen bond with water. Tapi kalau dibandingkan dengan propanoic acid, the number of hydrogen bond that can form between water adalah kurang compared to propanoic acid. Sebab hanya hydroxyl group boleh membentuk hydrogen bond with water. Tapi for the propanoic acid, the oxygen kat sini dengan the OH, dua-dua tempat boleh membentuk hydrogen bond with water. How about pentane? Pentane, so nampak tak? Tak ada oxygen directly attached to hydrogen in pentane. Therefore, pentane, dia adalah non-polar, cannot form hydrogen bond with water. Therefore, pentane is the least soluble in water. So how to arrange? So we will expect propanoic acid most soluble sebab boleh membentuk the most number of hydrogen bond with water. Diikuti dengan 1-butanol, and then pentane paling not soluble in water. Okay, so decreasing order of solubility in water. So tadi, which one is more soluble in water? So it's the propanoic acid. So kenapa propanoic acid is more soluble in water? Because can form more hydrogen bond with water molecule. Okay, so so the second point, kita tengok hydrophobic area. So for the propanoic acid, so this is the hydrophobic area. This is the hydrophobic area. In the 1-butanol, this is the hydrophobic area. Nampak tak? In the 1-butanol, the hydrophobic area is larger compared to propanoic acid. So this is another reason kenapa 1-butanol less soluble in water. So 1-butanol has larger hydrophobic area compared to propanoic acid. Thus, 1-butanol is less soluble in water than propanoic acid. Sebab dia punya hydrophobic area lebih besar. And then how about pentane? So pentane is the least soluble in water because it cannot, dia tak ada oxygen directly attached to hydrogen. Okay, tak ada hydrogen directly attached to oxygen dalam pentane. So it cannot form hydrogen bond with water. Okay, so selain daripada itu, so pentane also has very large hydrophobic area. Okay, so the whole thing is the hydrophobic area. Therefore, it is least soluble in water. So basically, solubility in water. So So basically, solubility in water we can discuss in two ways. So satu, pertama, we discuss in terms of hydrogen bond. So the compound yang boleh membentuk lebih banyak hydrogen bond with water, more soluble. Second factor, we talk about the hydrophobic area. Makin besar the hydrophobic area, less soluble is the compound in the water. So now we move on to look at the third, the last physical properties of carboxylic acid. So the first part of acidity, kita sudah tengok, this is just a revision. So basically carboxylic acid, phenol, water, and alcohol, they are weak acid. Okay, so how to know which one is the most acidic? So mesti ingat kita tengok in terms of stability of the conjugate base. Okay, so more stable is the conjugate base, more acidic is the acid. Okay, higher the stability of the conjugate base, higher the acidity of the acid. Okay, makin stabil the conjugate base, makin acid is the acid. So, and then acidity is determined by two effects. The resonant effect, so apa maksud resonant effect? Bermaksud melibatkan pi electron. For example, the benzene ring, the negative charge on the oxygen can be delocalized into the pi system of the benzene ring. So benzene ring ada pi system. Dia boleh stabilize the negative charge on oxygen, boleh masuk ke dalam benzene ring. Okay, and stability in effect ini kita panggil resonance effect. Or dalam carboxylic acid, the negative charge on the oxygen, okay, it can be delocalized between two very electronegative oxygen atoms. Okay, so remember in the carboxylic acid, mana pi system dia? So here is the pi system. Okay, and the negative charge ini boleh bergerak masuk into the pi system of the carboxyl group. Of the carboxyl group. So, an effect ini kita panggil resonance effect. Okay, sebab melibatkan is called inductive effect. Inductive effect melibatkan electron donating group such as alkyl group. So conjugate base sudah kaya elektron. Alkyl group bagi lagi, so will decrease the stability of the conjugate base. Okay, so conjugate base menjadi tidak stabil, so acidity of the acid decrease. And the electron withdrawing group, kita akan tengok nanti, such as halogen. So halogen, electron withdrawing group tarik electron away, pull the electron away. So when pull the electron away, it can stabilize the conjugate base, so can increase the acidity. So now we shall look at between the carboxylic acid, phenol, water, and alcohol. Carboxylic acid, the most acidic. So why the most acidic? Okay, so carboxylic acid, the most acidic, because dia punya conjugate base ini, so this is the conjugate base, paling stabil. So why the stabilized conjugate base ini paling stabil? By the resonance effect. Okay, so basically the negative charge on the oxygen ini boleh bergerak antara, can be delocalized between the two very electronegative oxygen atoms. Because of that, the conjugate base more stable. So more stable, therefore carboxylic acid most acidic. Diikuti dengan phenol. So phenol, it is less acidic than carboxylic acid. Kenapa? Because ini conjugate base dia. So for phenol, the negative charge on the oxygen ini, it can be delocalized into the pi system of the benzene ring. Okay, it can be moved into the Okay, so move into the pi system of the benzene ring. So benzene ring adalah carbon. Kalau berbanding dengan oksigen, okay, so kalau banding dengan oksigen, okay, let me draw first. So adalah kurang efektif, okay, to reduce the electron to reduce the electron density compared to oxygen. So because of that, untuk phenoside ion conjugate base untuk phenol ini adalah kurang stabil compared to conjugate base of carboxylic acid. Okay.